Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you are watching my channel Chemistry Solutions. So, today in this lesson, we are going to do the paper that is 062062. This one is the paper 6, alternative to practical, from February March 2024. This paper is of 1 hour, and the maximum max marks for this paper are 40. Calcium carbonate is an insoluble salt. Here is basically the calcium carbonate. This one is insoluble salt, and insoluble salt, always remember, is prepared from two solutions. So here in this question they have used two salt solutions, that are calcium chloride and aqueous sodium chloride. Okay, so this one is the calcium chloride and sodium carbonate mixed together to give us one solid calcium carbonate with one soluble salt, that is sodium chloride. So this is the apparatus, which the procedures which they have shown us and asked the question. Name the apparatus labeled A. So this one is the apparatus labeled A, used to stir. This is the stirring rod or the glass rod. B part is suggest why the mixture is stirred. In step 2, basically stirrer is used to mix the substances evenly, so that's why this glass rod is used to mix the substances. After step 2, the student filters the mixture to remove the solid calcium carbonate formed and collect to filtrate. Draw a label diagram to show the apparatus used for this filtration. So this one is the apparatus. You have to draw the label diagram along with the filter funnel, residue which will remain behind, that is our insoluble salt, that is the calcium carbonate, is the insoluble salt, filter paper, filtrate, and the filtrate will be um, our soluble salt. Here is our, and the insoluble salt is calcium carbonate, and residue is basically the calcium carbonate, and filtrate is of our soluble salt, that is sodium chloride. Okay, so sodium chloride is a soluble salt which is used in the as filtrate in the filtration process. Now next question is, the solid calcium carbonate obtained by filtration is not pure. So it is not pure. What is the reason behind why it is not pure? Basically, there can be the some of the particles of calcium chloride or sodium chloride can remain at the surface of the insoluble salt. So that will be, it can be act as an impurity in calcium carbonate salt. Describe how the substance you have identified in D1 can be removed from the calcium carbonate. So how we can remove calcium chloride and sodium chloride from this mixture, from the calcium carbonate insoluble salt? So both of these two are the soluble salts. So by pouring water over the residue in the funnel, we will proceed on accordingly to remove these impurities. Next question is, describe a test the student can do on the filtrate obtained in C to show that the calcium chloride used in excess. Give the results the student obtains if the calcium chloride is in excess. The point question is, we are proving and we are testing filtrate, and we are doing some of the test. If calcium chloride, basically result students obtain, if we have obtained the calcium chloride is in excess, what we will do? For this purpose, we will identify first carbonate ions. If we will add dilute hydrochloric acid, so it means there are no carbonate ions, because all carbonates are used up to make an insoluble salt, that is our calcium carbonate. So calcium carbonate is an insoluble salt and remained on the filter paper, not in the filtrate, right? Filtrate is our product, where filtrate is basically our soluble salt, whereas our calcium carbonate is our insoluble salt. So first we will check either the carbonate ions are present or not. If we will add dilute hydrochloric acid on filtrate, that is basically the sodium chloride salt NaCl, or we are testing the calcium chloride as well. For this purpose we have to add um, we have to check the calcium ion for their excess presence. So we will use calcium ions. Add for calcium ions, this is our cation. We can use aqueous sodium hydroxide to test the cation. If white precipitates are present, then we will say solid residues are there. This basically white precipitates of solid residue. White precipitates of calcium hydroxide will be formed when calcium ion reacts with sodium hydroxide in its aqueous solution. So next question is question number 2. It's based on basically titration. A student investigates. So you have to focus on the question what basically information is given to you all. A student investigates the reaction between the sodium carbonate, okay, and two different solutions of dilute hydrochloric acids labeled A and B. The student does 3 experiments. Experiment 1, rinse a burette with distilled water and then with the dilute hydrochloric acid. Okay, burette always rinsing. If we are talking about the rinsing of the burette, first we have to wash it with distilled water, then we have to wash it along with that liquid which we are going to use in the burette. It can be an acid, it can be an alkali. So rinse a conical flask with distilled water, fill the burette with the dilute hydrochloric acid A, run some of the dilute hydrochloric acid out of the burette so that the level of the dilute hydrochloric acid is on the burette scale. Remember one thing, it's a very key point. If we are filling our burette, for example, this one is our burette. This one is the graduated one. If you fill it, then run off this tap and fill the whole of the fill the gap which is present here at the mouth of the at the lower end of the burette. So open it and run it. Why we are going to run some of the dilute hydrochloric acid out of the burette? So that the level of hydrochloric acid is on the burette scale. So due to this reason we will open it and try to run some of the acid to meet the level of the burette scale. Record the initial burette reading. Use a measuring cylinder to pour 725 centimeter cube of aqueous sodium carbonate into the conical flask. So we can use pipette as well. Add 5 drops of methyl orange indicator to the conical flask. Stand the conical flask on a white tile. So remember, if we are going to use our if we are going to have our conical flask on the white tile, the purpose of white tile is to make sure the change of color which we observed should be observed at the exact time. So there will be there will be the white tile under the conical flask to observe the clear change in the color of the indicator. So add 5 drops of methyl orange indicator to the conical flask. Stand the conical flask on a white tile. Slowly add dilute hydrochloric acid A from the burette to the conical flask while swirling the flask. Record the final burette reading. So in the experiment 2, refill the burette with the dilute hydrochloric acid A. Again we are going to repeat this experiment with A. Run some of the dilute hydrochloric acid out of the burette so that the level of the hydrochloric acid is on the burette scale. Okay. Record the initial burette reading. Empty the conical flask and rinse it with distilled water. Use the measuring cylinder to pour 25 centimeter cube of aqueous sodium carbonate into the conical flask. Add 5 drops of thermophthalene indicator to the conical flask. Stand the conical flask on a white tile. Slowly add dilute hydrochloric acid A from the burette to the conical flask, while swirling the flask until the solution becomes colorless. Record the final burette reading. So third experiment will be done. Repeat experiment 1 using dilute hydrochloric acid B instead of dilute hydrochloric acid A. You all can see that here methyl orange indicator is used for the experiment along with the dilute hydrochloric acid one. And in the second experiment, thermophthalene indicator is used along with the same acid, only the change in the indicator. So in that experiment 3, we are using, they have used the hydrochloric acid, dilute hydrochloric acid B rather than A. Now let's have a look on the questions which they have asked to us. Use the burette reading. So you people must know how to read the from top to bottom. We have to read like 26. The final reading is 26.2. This one 0.2. Here are again you can read 12.5, 6, 7, 8, 9. So you have to read it from top to the bottom. So readings are here 26.2, 12.9, 39.1. All are the final readings. Initial readings are 0.8, 0.2, 1.0. You people can check the final reading of this 39.1. And here you can check the initial reading of experiment 3, that is 1.0. So we will subtract these values to get the volume used. This one is the hydrochloric acid. Here is a big difference between experiment 3 and experiment 1. So there are some reasons why their readings are so much different. So state which solution of dilute hydrochloric acid A or B is the more concentrated. Explain your answer. So always remember that the more concentrated solution use the less volume, and it will be a reactive one and use the less volume. So we can see from our result which titer is having the less volume. So if you can see that the S exactly the dilute hydrochloric acid A as volume of A is lower than the volume of B. So you can see the volume of A is lower than the volume of B. Describe how many times more concentrated this solution of dilute hydrochloric acid is than the other solution of dilute hydrochloric acid. So we will take the titer value 3. You can see here are the titer value 3 and divided it with 1, 25.4, and we will get our answer that are 1.5. Compare the volume of dilute hydrochloric acid A used in experiment 1 to the volume of dilute hydrochloric acid A used in experiment 2. Greater volume is used in experiment twice as much. Wherever you are using a greater volume, you can predict the values, how much amount is this. You people can check that compare the volume. We have to do the comparison of the volume of dilute hydrochloric acid A, which is used in experiment 1 and experiment 2. You people can check what are the answer for our experiment 1 and experiment 2. 25.4 and 12.7, almost double the values. So you can check its volume is as twice as much. So greater volume is used in experiment 1. Now deduce the volume of dilute hydrochloric acid B. Let me check the value. Yes, it's okay. the greater the value at experiment 1. So, okay, reduce the volume of dilute hydrochloric acid B required to reach the end point if experiment 3 is repeated using thymophthalin indicator instead of methyl orange indicator. Use your answer to C1. Okay, we will use our answer to C1. C1 is saying that the double the value the value of it is. We will divide these two values 12.7 titer 1 divided by titer 2 multiply by our third experimental value, that is titer value 38.1. So answer will be 19.05. You people can write 19.1 as well. In the D part, at the start of the experiment 3, now come towards experiment 3, the burette is rinsed with distilled water and then with dilute hydrochloric acid B. Identify the substance removed from the burette when it is rinsed with distilled water at the start of the experiment 3. Definitely, there will be the dilute hydrochloric acid, the remaining dilute hydrochloric acid is going to be removed from the burette. So it will be the dilute hydrochloric acid. Describe how the result of titration change if the burette was not rinsed with the dilute hydrochloric acid B after it had been rinsed with water. So the large volume of acid will be needed. If the number of moles of water is there, then large volume of acid will be needed to neutralize the reaction. So explain why the conical flask is not rinsed with aqueous sodium carbonate after it is rinsed with water. Why it is not needed? Because increases volume of aqueous sodium carbonate. Why the conical flask is not rinsed with aqueous sodium carbonate? Because of the increases volume of aqueous sodium carbonate, so it will not affect in the usage of the volume of acid. So explain why a white tile is used during the titration to observe the color change more clearly. So that's why it is used over there. Describe the effect. So you have to describe the effect on the result of warming the aqueous sodium carbonate. There will be no change, because what will happen when you will warm a sodium carbonate used in experiment 1 before carrying out the titration? No change. Volume of Na2CO3 doesn't change. So this is the reason, because volume doesn't change. Question 3 is on the identification of fines. So you have to attempt this question by using the answer sheets, salt analysis sheets given at the end of the paper. You will use it. So we are going to read. Solid C is ammonium iodide. Okay. The student dissolves solid C in water to form solution C. Solution, it will become solution. The student divides solution C into 3 approximately equal portions. Complete the expected observations. So observations are those which you can see with your eyes. So that's why you have to be more precise about the observations. Okay. To the first portion of solution C, the student adds about 1 centimeter cube of dilute nitric acid followed by few drops of aqueous barium nitrate. So if there are ammonium, let me check which substance is there. If there is ammonium iodide, yes. If there is ammonium iodide, so for the ammonium iodide, if we will add dilute nitric acid, there will be no change. If we will add dilute nitric acid followed by few drops of silver nitrate, then in that case iodide ion give us the yellow precipitates of silver iodide. So this one is the solid which will formed by reacting with dilute nitric acid and silver nitrate. To the third portion of solution C, the student adds aqueous sodium hydroxide. Just only to add aqueous sodium hydroxide, there will be no change on the ammonium ions which are present in ammonium iodide compound. Okay, so no change. The student warm the product. So after heating, a gas will be given off, that will be the ammonia gas, which will turn red litmus paper blue. Test on solid D. Another solid D is there. Do a flame test on solid D, yellow colored flame. A sheet will be given to you. All you people can see and observe the color over there. It will be of sodium flame color. Yellow flame color is of sodium. Gently heat about half of the remaining solid. We are going to heat it. After heating, hold a strip of steam is given off. When we are going to heat it, steam is given off and condensation forms the top of the boiling point. Hold a strip of anhydrous, point is anhydrous cobalt 2 chloride paper at the mouth of the boiling point. So there are steam at the mouth of the boiling point. So if the color changed from blue to pink, first in anhydrous color is blue, and the anhydrous cobalt chloride will turn into hydrated one, and the color of hydrated cobalt 2 chloride is pink. Okay. Dissolve the remaining solid in water, remaining solid D in water to form solution D. Divide solution D into three portions. To the first portion of solution D, add aqueous ammonia dropwise until an excess. Green precipitates are observed which is insoluble in excess. So green precipitates may be of which is insoluble in excess. So both Fe2 plus ions and chromium ions give us same test. Green precipitates which are insoluble in excess ammonia. But if aqueous sodium hydroxide written here, then chromium ions will dissolve in aqueous sodium hydroxide, whereas iron ions, Fe2 plus ions, will not dissolve in aqueous sodium hydroxide. It will remain insoluble in both cases, but chromium ions dissolve in sodium hydroxide. So these are the key points which are given at the end of this paper. So to the second portion of solution D, add piece of aluminum foil, about 5 centimeter cube of aqueous sodium hydroxide. Heat the mixture formed and hold temperate litmus. If you are going to heat the solution, add sodium foil. Heat the mixture of sodium and hold temperate litmus paper at the mouth of the boiling point. It turns red, litmus paper remains red. So no change. To the third portion of solution D, add about 5 centimeter cube of dilute nitric acid. Bubbles any gas formed through lime water. So lime water turned milky, it means carbon dioxide gas is present. So state the final color of cobalt 2 chloride, that will be the hydrated cobalt chloride, and it will be pink. State what ion the observation test 4 shown is not present. Basically at the test 4 they have done the heat with by using aluminum foil. If we use the aluminum foil, this is the test for the nitrate ions. So nitrate ions are not present. So that's why there is no ammonia gas which will change red litmus paper to blue. So we do not have this. So nitrate ions are not present. So move on. F part, identify the gas produced in test 5, that is the carbon dioxide gas, because it turns lime water milky. Identify 3 ions. Yes, the yellow flame with sodium ions, Fe2 plus ion or chromium ions with green precipitates, carbonate ions because it turns lime water milky. So these are the ions in solid D which are present, and we have identified by using the sheet given at the end of this paper. So next question is the planning question, the very important questions. You always try to handle this question very vigilantly, because so many steps are there in your planning questions. So you have to score all the full mark, 6 marks for this question. For this, what we are going to do, use the bullet points to answer this question. Always remember, use bullet points. When excess dilute sulfuric acid is added to solid zinc, hydrogen gas and aqueous zinc sulfate are formed. These are the products which are formed. Plan an experiment to show that copper is a catalyst. Okay. We have to plan an experiment to show copper is a catalyst for this reaction. Your plan should include how the result of the experiment will show that copper is a catalyst for this reaction. Always remember that the catalyst only speed up a chemical reaction. It do take part in a chemical reaction but remain unchanged at the end. So it is not going to part of the product. Okay. You are provided with zinc powder, dilute sulfuric acid, copper powder, and common laboratory apparatus. Always remember, whenever you are writing the apparatus, conical flask, test tube, boiling point gas ring, stopwatch, he used just this word, that common use laboratory apparatus are provided to you. So with the common laboratory apparatus, we will first write the apparatus which we have needed, and we are going to, you people can draw a diagram to support your answer. You can have a gas syringe here, and here the stopwatch, and label it. Without labeling your this one is the gas syringe, test tube, if I will just, and this one is the conical flask. Okay. So use the bullet point to answer this question. Experimental procedure, we are moving on. Now we are moving towards our planning question. Add a, first of all, we will add a measured volume of dilute sulfuric acid. Okay, we will measure the volume of dilute sulfuric acid. Then we are going to add measure mass of zinc, because reaction is between acid and metal. Measure time to collect volume of gas. First of all, we will check the volume, record the volume, how much volume is used. Use, for example, we can write in our planning that for example, collect a set of volume of gas. Mm, for example, you have collected 10 centimeter cube in 10 minutes. I'm just going to give you an example. Use of suitable reaction vessel. Repeat but add a measured amount of copper as well as zinc. Now repeat same experiment, but now at this point we are going to add copper as a catalyst in it. Filter out the copper after reaction, completing the reaction. We are going to remove copper because copper doesn't react with dilute HCl, with dilute acids. The filter out the copper from the solution, dry the copper, and then weight the copper. There will be no change at the mass of the copper. Copper act as a catalyst if mass doesn't change. More gas collected in less time when we are going to add copper as a catalyst in this reaction. So more gas collected in less time. Not as I have tell it to you that we are collecting with the same amount 10 centimeter cube of gas, but now this time in 5 seconds or 5 minutes. If I have written in the 10 minutes at above, there are so many minutes, you can use seconds as well. So just I have given you an example. So this is the end of the planning question, where you people are using all of the methods along with the appropriate diagram, apparatus, and all of the steps. So this is the end of the paper. That is our alternative to practical paper of this year 2024. I hope so that you people have learned so many things. So consistency is the key of success. Signing off, Miss Aisha Manzoor.